Okay, I'm now going to use synthetic division to solve for the other missing solutions and also list the other possible solutions. First of all, let's look at f of x. I'm going to start off interestingly with f of x equals x cubed minus 1. Before you ever use synthetic division, you want to make sure you have what we call full representation. Plus 0x squared plus 0x minus 1. I did that simply because I don't have any x squareds, any x's, so I do that. Even when you divide, you should do the same thing here. Now, if you recall, we talked about p's and q's. Your p's is the number in front, that's a 1. Your q is the number behind, that's a 1. Your possible solutions are 1 over 1, that's it, plus or minus, so our answer is going to be 1 and negative 1 and 1. Synthetic division says pick one of your solutions. I'm going to try 1. 1, 0, 0, 1. This is called your remainder column. This is the coefficients. This is a 1, that's a 0, that's a 0, and that's negative 1. Now, if you use the remainder theorem says, let me clean that up a little bit, minus 1. Remainder theorem says if I go up here and put in a minus 1 for my x, I get minus 1 cubed minus 1 equals minus 1 minus 1. That gives me minus 2. I know minus 1 is not going to be a solution or a factor because it's giving me minus 2. Remaining theorem, this should be 0. So now let's stick in f of 1. I get 1 cubed minus 1, which gives me 0. So I know 1's going to be a solution. Let's see what happens. Synthetic division says bring down this first number, multiply. 1 times 1 gives me 1. Add those together, gives me 1. 1 times 1 is 1. Add those together. Just remember, bring down, multiply. What's 1 minus 1? That gives me 0. I know I have a solution. Since my original problem was started with an x cubed, I now know this guy going to be an x squared plus x plus 1 equals 0. It's quadratic. Do you love me? See if it factors. This one doesn't factor, so you got to go use the beast. Let's see what you get. I know it's going to be 1, 1, 1, 1. I'm going to clear this page up. Give me a new page because I want to go back and go x. I want to go back and I got x squared, so I know this is going to be minus 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 times 1 over 2 times 1. If you continue this, we're going to get a minus 1 plus or minus the square root of minus 3 over 2, which gives us a minus 1 plus or minus I square root of 3 over 2. So that's your other two solutions. One of them is going to be what? One real, one positive real. The other one's going to be two complex. And if you check Descartes, it will give you that possible solution. That's pretty neat. Let's do one more, make it a little longer. I'm going to go to File, New. And this time I'm going to ask myself 3x cubed plus 6x squared minus 15x minus 30 plus 6, right? Let's get rid of this for a second. Plus 15 plus, well, that's just nasty, plus 15x, right? Now, if you notice something here, don't know why my pen's not writing. Let's jump over here, get some black. Plus 15x. That's going to be my f of x, and that's a 3. What's my p? 3. What's my q? 30. Q, p, my q becomes 30. 1, 2, 3, 5, 6, 10, 15, 30. My p is 3. 1, 2, 3. Who's on top? Q's over p's. So I'll have a 1 over 1, 1 over 2, 1 over 3. Now this 2's got to dance with everybody. 2 over 1, 2 over 2, 2 over 3. This 3 dances with everybody. 3 over 2, 3 over 3, and so on and so on. Then you're going to reduce till you get down to what? 1, 1/2, 1/3, 2, yada yada yada. Notice something. Let's start this problem again. File, new. I'm going to rewrite it again as f of x equals 3x cubed plus 6x squared minus 15x minus 30. I could have taken out a 3 from the very beginning, be left with x cubed plus 2x squared minus 5x minus 10. Now my q is 10, my p is 1. So watch how cool this is. This becomes 1, 2, 5, and 10. This becomes 1. So now I just have to deal with 1 over 1, 2 over 1, 5 over 1, 10 over 1, plus or minus. So my answer is going to be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. The hard part is taking that answer, sticking it into your f to see which one gives you 0. I'm going to try f of 1 first. Hopefully I'm lucky. I get 3 times 1 is 3 plus 6 is 9. Nope. 9 minus this big number here is not going to be 0. So let's try 1, a negative 1. That's not going to be 0. Try 2. Oh lordy. So I'm going to try 3 times 2 cubed plus 6 times 2 squared minus 15 times 2 minus 30. I get 3 times 4 is 12 plus 24, and I don't think that one works. So you got to keep plugging those numbers in to see which one works. Okay. So let's see what we're going to try now. I'm going to clear the page, rewrite the function again. I think it was what? F of x equals 3x cubed plus 6x squared minus 15x minus 30. Let's try minus 2. 3 minus 2 cubed plus 6 minus 2 squared minus 15 minus 2 minus 30. I need to pull this screen over a little bit. I don't think you can see it. Okay. Now, let's see what we get. F of minus 2, negative 2, minus 2 cubed is negative 8, minus 24, plus 24. Negative 15 times negative 2 is 30, minus 30. Those cancel, those cancels. We get f minus 2 equals 0. Woohoo, cookie with grease. We know that's a solution, so we know x minus 2 is a factor. Now we can use what? Synthetic division to see if we can get the other guys. Here comes my box. I'm going to put a minus 2 in there. That's an x plus 2 is a factor. My coefficients was 3, 6, 15, minus 30, right? Bring down to 3, multiply 6, 0, 0, minus 15. Because you added those together, I get 30. I get a 0. I'm excited because that tells me that now I have a quadratic. That's 3x squared minus 15, because that is what? 0x right here. Minus 15 equals 0. How do you solve that? 3x squared equals 15 divided by 3 divided by 3. X squared is equal to 5. Take the square root, take the square root. X is equal to what? Plus or minus the square root of 5. So my three solutions would be x equals minus 2, x equals square root of 5, x equals minus 5. If you had to write the polynomial again, and you want to see what it looked like factored, you would have x plus 2, x minus the square root of 5 times x plus square root of 5. Dance all that out, and it would be interesting to see what it would turn out to be. So that's how we do that problem. Okay.